Hello, everybody, and welcome to our webinar today, OSDP Retrofits and Tools. Today, we have with us Tony Diodato and John Urin from Cypress Integration Solutions. Tony Diodato is the founder and Chief Technology Officer of Cypress Integration Solutions and the co-chair of the Security Industry Association's OSDP Standards Subcommittee. Tony has over 40 years of experience in access control protocol and format conversions, including solutions to overcome Wiegand shortcomings. Tony is a longtime contributor to the development of SIA's Open Supervised Device Protocol, or OSDP standard, and a frequent speaker for many industry events. John Urin is the operations manager at Cypress, and John has been with Cypress since 2008. During his tenure with the company, he has also served as engineering coordinator, and product development engineer. John also works with Cypress interns through his work as a coach and mentor for FIRST robotics teams. Very cool. Completely ripping and replacing system to install OSDP isn't always in the budget. And in today's session, our two OSDP experts, Tony and John, are going to demonstrate how to retrofit Wiegand and legacy systems into interface with OSDP readers and other components, highlighting the tools needed for OSDP testing and installation, and will also preview updates to the specification. My name is Julie Rolls. I am the training manager here at PSA. I will be moderating our platform. I have very few quick housekeeping items before I hand it over to these gentlemen. First, if you happen to have any questions throughout the course of today's presentation, please type them into the question panel. We will have time for Q&A at the end of the presentation. I will also be monitoring the chat should you run into any technical difficulties, and I will do my very best to get you back up and running. With that, I'm going to hand it over to Mr. Diodato and Mr. Urin. Welcome, gentlemen.
Welcome, everyone, and thanks for joining us today. Tony Diodato.
Yeah, I'm John Urin.
Okay. Well, I guess, are you going to kick it off?
Yeah, we can jump into this. So, we're talking about retrofit and tools. So here we have a comparison of an OSDP versus a legacy wiring with a Wiegand reader. So you can see we have the normal data, a couple LED lines, and then a buzzer compared to the same functionality as an OSDP reader. But using commands, you actually reduce the LED lines and the buzzer lines to communicate over the communication lines.
So. Right. Just something to keep in mind that we're going from a minimum of 7 wires in this case down to 4, and getting the same functionality over those 4 wires.
Yeah. Oh, and something to note too, we will be showing a demo at the end of this. So we're going to kind of run through these slides fairly quickly, and then we're going to show kind of a hands-on demo featuring some of the things that we display in the slides. So going into the major differences of the two different protocols, Tony, you want to talk about the Wiegand?
Yeah. So Wiegand is, as we know, is referred to as simplex, meaning it only goes in one direction on the wires. So that inherently makes it unsupervised. And you would need discrete wires to implement whatever features you want. So if you need 2 wires to control an LED color, for example, you want more than just 2 colors, you'd need an extra wire. So you start adding up all these wires to get the functionality. And the big one is the Wiegand vulnerability. And for those of you who may not be familiar, it's just that there are so many, if you go to any hacker convention, or there's even some presentations in SIA at the trade shows to show how easy it is to hack Wiegand and overtake it, eavesdrop on it, and actually deny service. So we want to eliminate Wiegand from the attack side of our doors as quickly as possible. And the way to do that is through the OSDP protocol, which gives you bidirectionality. So there's a conversation between the card reader and the panel, which makes it fully supervised, as well as being able to get all the functions over that same pair of wires. But the best part is the fact that you can encrypt it and authenticate that signal. And we could never do that with Wiegand before.
Some of the configuration parameters that you'll actually have to configure your OSDP devices, you'll actually have to configure the communication speed, so somewhere between 9600 and 230 baud, as well as your per field device ID, so somewhere between 0 and 127. So multiple devices would require individual IDs. And then your security key can go up to 128 bits. Some of the optional application parameters is the actual LED color. So you can actually set different LED colors, not just red and green. So for access denied or granted, you could do a different color. And then there's different input thresholds also.
Yep, and we'll go into some of the reasons for the configuration parameters, but essentially it's just those three. And there are many ways of configuring that easily in the OSDP implementation. So some of the installation challenges back in the day, Wiegand, I had someone say, what's all this talk about interoperability in OSDP? Wiegand was always interoperable. Wiegand is Wiegand. And I'll just put it into context. Cypress has been around 40 years, and we sold $1 million a year of devices that make Wiegand interoperable with Wiegand. So if that's any indication of the lack of interoperability, just want to highlight that. And again, being able to supervise Wiegand was, just one of those, as we were talking about it in New York, and we all agreed it was shameful that we couldn't supervise Wiegand all these years. So if the reader failed for whatever reason, you didn't know about it until you actually tried to use it. And then, of course, the security, as we mentioned before, needing to protect that information going over the wires. So the challenge to overcome some of the Wiegand shortcomings is going to OSDP, and it does require a little bit of a different mindset. You have to think about configuration of the device when you take it out of the box. It may not default to the configuration you need to be compatible with the controller it's going to talk with, and also troubleshooting in the field, making sure that you know why, if it isn't working, why, and how to get some tools to help you troubleshoot that.
And as Tony mentioned earlier, the vulnerability is the attack side of the door, right? So we sell the OSM CPI, which actually takes an OSDP card reader that's outside of the building on the attack side and lets you take OSDP into your building, into a secure area. So you can put this device next to your panel. So it'll take OSDP in and then output Wiegand to your panel. So you don't actually have to upgrade your panel, but you get all that extra security from the panel to the outside of the building. So another tool, as Tony was mentioning, where you have to do some configuration and you have to try to understand what's happening if things aren't working properly. We actually have a trace tool. So some ACUs actually have this built into them, but not all of them do. So this tool is a non-panel required standalone tool that you just run on a laptop. And you'd be able to record and see what's actually happening with the communication and the packets. And then you could save that file, send it to us, so that way we could look at it, analyze, and say, hey, it looks like your wires are backwards, or you have these other issues, blah, blah, blah. Or, your wires aren't, fit for this data communication or something. So that way we could help you troubleshoot in the field a lot faster and get your site up and running.
Yep, well put. It's just one of those things that, especially in the beginning, as you're learning, and as we're all learning how OSDP unfolds in the field, it's great to have these traces so that those of us who are working on the specification can find what some of the trip points are or pain points, and remediate them in the specification itself.
So here we have highlighted the FTDI cable that we were mentioning, the RS-485 adapter. That would plug into the laptop to run the trace tool. Another tool that we have is the OTT 2100. We also call it the ComSet tool. The idea behind this is to configure those parameters we mentioned earlier. If you don't want to drag your laptop out of your bag, or you're on the field and you're up in a bucket or something and it's not easy to configure your device, you can pull the ComSet tool out, plug it in through a couple of dip switches, turn it on, setting the parameters, and then you unplug and you're up and running. So the trace tool is more for if you have problems, and the concept tool is more for the actual configuration to get you up and going in the field.
And just as a note, some of the pack software will already have this built in different ways. This is just sort of a standard way of doing it. So you can be familiar with, if you're working with different manufacturers, you would only have to have this one set of tools to configure any peripheral device.
Another device that we have is more of a convenient tool for bench testing. So this is called the OSDP hub. The idea is you can plug in multiple readers, you can plug your ACU in, your trace tool, and very quickly you can turn different devices on and off. So if you want to configure a specific device, you can actually kind of shut the other devices off. So it's just the comms that are in that individual device. If for some reason your wire colors are wrong, or maybe you just accidentally wired the polarity of the 45 incorrectly, there's a convenient invert button. So you can actually turn the devices off, inverted, and then of course on, so that way each of them can communicate with each other. People have used it in the field, but it's definitely, it's something that sits on a lot of people's desks here in the office. And
yeah, it's sort of the equivalent, again, I'm dating myself, but back in the day when you were working with RS-232, you needed all kinds of gender changers and 9-pin to 25-pin adapters and the all-important null modem to swap pins 2 and 3. So this is sort of the equivalent of that in the RS-485 world.
And then the final tool that we definitely take advantage of is actually called a SAILI device. It's a logic analyzer. So it's a great little USB analyzer. So instead of toting a giant, oscilloscope type machine out into the field, you have this super small USB powered oscilloscope that can give you exact information on what's happening on the lines.
Yep. And just as an example of one of the outputs from this device, and we'll actually demonstrate it in a few minutes, but it can actually interpret what the protocol is doing. You can see the transmit and receive packets, as well as the analog values, and actually see if there's any ground faults or noise on your 45 lines.
Yeah, so we're gonna head into the demonstration. So I just need to do a quick change of our screen here and pull up some stuff. So here's the top-down view and Tony in my elbow. So
You're out of the shot, John.
yeah, that's all right. So here in the top right, we have the trace tool. Here in the middle, we have the logic analyzer, and then we have our little cheat sheet for the comm setter over here. And then over here, we just have our different setups. So Tony, you want to take them through the demo?
Okay, well, what are we going to show first?
I think start with the Wiegand reader.
Okay. Well, what we have over here is a access control panel, which is configurable for Wiegand on one side. So just like we've been used to for decades. But on the other side, it's actually OSDP. So we can directly connect OSDP readers to that. But to show you the ease of retrofit, I'm going to present a badge to a Wiegand. Well, that was pretty far to read. That's a typical Wiegand read. So I guess you can see the LED turning, beeper going off. That's all controlled by the panel.
Access granted up here.
Yep, and John's showing that. And which one? Oh, I gotta stop moving these things, right? So what we're showing is the equivalent. This is an OSDP reader going to our converter and then converting it to Wiegand. So essentially the retrofit device. So if we present it, we get essentially the same thing, almost exactly the same thing. Access granted, and the LED and the beeper act exactly the same. So as far as the panel was concerned, that was connected to a Wiegand reader, and that's to make it very easy in the field to retrofit. But the beauty is outside of the door, or on the vulnerable side, the attack side of the door, you've got OSDP and its encryption and authentication. So what's next?
Yeah, so finally we have our OSDP reader that's connected to our panel through the OSDP or through the OSM hub. This is set up so that way if we needed to comm set the reader for some reason, we could do that very easily here. As well as we have our SAILI device connected so that way we can actually see what's happening.
Yep. So we just have some clips that are clipped right onto the RS-45 lines. And this device, because we're analyzing the signals, just needs a ground reference. So that's what our little black wire is there. Typically, you wouldn't have that in an OSDP installation. So we have the OSDP reader out of the box. We don't know what this is configured at, intentionally kind of left it in a default configuration. Our panel has been set up to poll, and we'll explain what's going on there. But it's going to search for this reader. So we're gonna go ahead and you just hit the green button there. That's right. Yeah.
We can hit.
Okay.
So we can see something's happening on the line, which we would assume is the panel trying to poll or communicating on the SAILI device. If we actually hit record on the trace tool, we'll actually see a PD capabilities request.
Right. Right. Now, that is the panel's way of searching for a reader that it expects to be configured and online. But right now, it's not getting a reply. So it's just going to sit there and keep polling until that reader shows up.
Which
so
currently, the reader is actually off. So we'll turn it on. So it's on the OSDP bus. It was powered on, but the 45 was actually shut off. And then we see that we're still getting a PD capabilities request.
Correct. So that means that the parameters are probably one of those three parameters is not set correctly. So by looking at this, and again, having the ability to, for example, right now you would say, well, I really don't know what's going on. You could send this trace or at least describe what you're seeing to an expert, back at the mothership, so to speak, and they would be able to say, oh, well, it's polling, it's looking for address 0, and it's not finding it. So first thing we want to do is make sure that our reader is configured for address 0. The reason there are addresses, you can put multiple devices on the same wire, up to 126 polling IDs. I don't recommend you put 126 devices on one pair of wires. 8, 16, 32 devices is not uncommon. So, John, what are we going to do to demonstrate the product?
So step 1 would be disconnecting the ACU from the OSM hub. So that's just turning the 485 off. And then we'll make sure that the reader is still connected to the hub, which it is. Then we will turn the 45 port for the comm setter on. And then at that point, we should be good to actually comm set the reader. So I'm just going to go ahead and flip the comm setter on. So the comm setter is already set up for 9600 baud and address 0 with all the dip switches off. We can see we're getting a blinking green, as well as on our trace tool, we can see we're getting polls and command accepted. So because the communication is only between these two devices, that means this thing that is basically pretending to be an ACU to tell the reader to be configured this way is going through properly. So I'll go ahead and turn the comm setter off. Now that we're confident our reader is using the right parameters, we're going to disconnect the comm setter from the hub, the bus, and then we'll go ahead and turn our ACU back on. And then now we see the same thing we just saw with the comm setter and the reader, but only between the panel and the reader, which is the poll and the command, as well as we're seeing a lot more information on the SAILI over here. So it looks like they're communicating. So we'll go over to the ZK Techo window and we'll try to scan a card read and access granted. So that means we got a successful card read through and we properly configured the reader to talk to the panel.
So that's typically what we're finding from feedback in the field is just that kind of that black box. Gee, I just don't know what's going on. You really need to see what the electrons are up to. It's a phrase that I know John's sick and tired of hearing, but we both use it as mentors to students on the robotics team. Is, just dive in. Don't be afraid to use the tools. Get in there and see what's really going on. And even if you don't really understand it fully, you can easily tell the difference between something communicating and something not communicating. So with that, I don't know if there's any other devices that we want to show.
No, I think the only other thing is just kind of, this is the CPI. If you
Okay,
bought
can hold
one
it up.
and yeah,
Closer. Okay.
yeah, so it just comes in heat shrink tubing or so that way it's just, easy to mount and access. And then, a standard, this is the other end that's plugged in the computer for the trace tool. This is the FTDI, the 45
Right.
adapter.
So with just the OTT 2100 and an RS 485 cable in your toolbox, and of course a laptop if you're going to use this, is pretty much all you need on a day-to-day basis for successfully installing and troubleshooting OSDP. So well, with that, and just one more mention of the hub itself, that is just for convenience. I mean, you could do the same thing we did by screwing and unscrewing wires. Obviously takes a little bit more time, and when you're doing bench testing, you just want to be able to do that quickly.
Yeah, and if you're in a situation where the reader is already mounted to a wall, you could just take those two wires, plug them into the comm setter, and you don't have to unmount everything and for configuration. So
okay, all right. I think we're good on time. I think that leaves us with some time for some Q&A.
Awesome. I did have a couple of questions that came in. First one is on the OSDP trace tool. Is this available from Cypress, or is it a third-party tool?
so the trace tool is
slide over some. I don't know if you're in the right.
Oh, here, let me switch back to this. So the trace tool is something that we made that we're going to be publishing shortly. I know we've had some third-party testers test it. So we're looking at the best way to actually distribute that going forward. So
Yeah, and it's available Linux, Unix, Mac, and Windows. So yeah, it's going through some validation right now just to make sure it's viable on all those formats or all those platforms.
Okay, awesome. This next one, I think this is a good one. When the CPI converts OSDP to Wiegand, does that create a security risk?
Well, again, I don't know if you want to flip back to the video so we can show that. Back to the camera. Yeah, there you go. All right. So yeah, that's an extremely good question. Now, if your Wiegand wires, that's what's vulnerable. Those it could be just 3 inches of Wiegand wire hanging on the outside or the attack side of the door. That's what's vulnerable. If you have twisted pair, the OSDP running encryption, then it's not vulnerable anymore. So you're bringing that wire as close to, and in fact, inside of your access control panel. So it's a locked box in a mechanical room, and the Wiegand is there inside the panel box itself. So it's just this section of wire that is vulnerable to attack. From this connector all the way to your reader, it's, I won't say invulnerable in terms of maybe 1 trillion years it'll take you to crack that, but it is as secure as it needs to be.
On basically this side, you can't buy a $70 item from Amazon to hack your door, but on this side you could, right? And the idea would be this side is all inside a proven secure location inside the building, deep inside the building.
Right.
Excellent. Can I use the OSDP converter with Wiegand reader? And if so, will it be secure?
Okay, so going the other way, if you have a Wiegand reader outside of your door, and you want to go to OSDP to go to an OSDP panel, for example, yes, that bit of wire is vulnerable. However, the real world, you may not be able to replace that reader for whatever reason. So if it can be mechanically hardened so that is not easily accessible, then you're not any more vulnerable than you were before. You're just able to take advantage of the OSDP future scalability,
as well as distance too. Yeah, in that circumstance, Wiegand is limited to 500 feet compared to OSDP, which is 4,000.
Yep, 4,000.
4,000 feet.
Yeah.
Cool.
Which that in that case is a different converter. That'd be more like our OSM 1000 or our OSM 2400 compared to the CPI. So
Correct.
I like this next question too. Can I reuse the same wiring in a retrofit?
There's the question. Everybody has that one. Yeah. Okay, so as I mentioned, we have had 4 decades of experience with RS-45 and Wiegand. I know the cable manufacturers hate for me to say this, but essentially Wiegand wire at less than 500 feet is essentially running 9600 baud right now. So the bit pulse widths of Wiegand are more or less equivalent to 9600 baud. So if you want to run that, you had no choice. You had to leave the wire. Pulling new wires is not palatable at the moment. Yes, you could get away with it. I'll put it that way. Running 500 feet at 9600 baud using OSDP. The problem is that, sure as anything, a year from now, someone's going to come along and say, hey, I'm going to put another device on that same pair of wires. It's been running for a year and the whole thing's just going to collapse. So yeah, you're on thin ice if you want to do that. So the best suggestion is to take this opportunity to replace the wire. That will future-proof it if you want to do enhancements later, because OSDP not only gives us those basic it overcomes those basic vulnerabilities of Wiegand, but it offers so much more in scalability, having multiple devices, and speed. The thing can run 230 kilobits a second, which would not work at all over that 500 feet of Wiegand wire.
This has been absolutely fantastic, gentlemen. I really appreciate the demo, as I know I like to see some of this in action, and you've done just a phenomenal job today. So really appreciate that. And that does look like all the questions that we had for today. And if anyone wants to review this again, we will be sending out a recorded version of this to you all. And make sure that you're visiting our website, which is psasecurity.com, to be sure that you're leveraging all that PSA has to offer. So this will conclude our presentation for today. I want to thank everybody, and I hope you have a wonderful rest of your day.
Thank you, everyone. And thank you, Julie.
Thank you. Bye-bye.
Bye.